This topic is not my field. Non-technical challenges. Actually, every time I'm solving only technical challenges, not non-technical. But there is my interpretation of what I'm thinking. Where is that non-technical thing? But in order to explain where's the issue, I have to go to the science and math behind that.
Okay, and Vidas, could you just move me away from your presentation? I can see myself in your presentation on the lower right corner, so it won't disturb
okay,
the others.
Maybe.
Yeah, you can close it right like this. Okay, thanks.
Thank you. Yeah, to science and math. Yeah, and for me, robotics is two things. It is hardware and software, and basically, I'm more involved in software development, but you know that robotics, it has to somehow make a decision, and mostly it has to be done autonomously. And when I'm talking about the software, I'm aiming to artificial intelligence, which is usually based on biological neuron. As you see here, there is a piece of brain tissue, and there is a several very sexy cells that makes us unique. And what is happening here, that we have dendrites, we have cell body, and we have axons. And usually it's drawn like this, from left to right, we got inputs through the dendrites. This signal goes to the cell body, and if cell body is stimulated enough, it shoots the signal back through axon and stimulates other neurons. And in that way, if neurons shoots together, are activated together, they join together. And most fascinating thing that is all neurons want to be connected. They want to be touched by each other. Maybe that's why humans like touch so much. Based on that thinking, the mathematical neurons are constructed, and based on that reasoning, how neurons are training, all that intellectual part is created. For example, if you have, it's still a biological concept of the human brain. For example, if you have some kind of sound which stimulates one neuron, and the sound is really annoying, and somehow the one neuron is connected to the leg, and the leg does some kind of motion, and the sound disappears, which was annoying. Instantly, those two neurons are connected together, but the connection itself is very weak. But when the stimulation signal, again, the sound will come again, which is annoying, the kick or motion of the leg will be appearing more frequently. Then connection between those two neurons becomes stronger, and the signal from one neuron to another neuron will go faster. Then it means that the training process is all about how to strengthening the connection between neurons. And in such way, the mathematical neurons are created. It's called perceptron. On the left side, we have biological neuron. On the right side, we have mathematical neuron. And mathematical neuron has same structure. The inputs goes to dendrite, is X, X2, X3. It connects to cell body which does summation. And after, if signal is strong enough, it shoots out the output. And the equation looks like this. It's simple sum and multiplication of signals. Yeah. And training of neural network model or artificial intelligence is all about how we can find these coefficients, double V, in order to get the output which is needed for us. And for that, we need a lot of data. Data can be any type of data. It can be time series data taken from market prices, can be images, can be data taken from Excel sheet, TXT files, SQL, any type. And these algorithms is replicating our human brains in order that brain itself is situated in a dark, wet place where brain actually do not understand from where the stimulating signal is coming. It does know and don't know. It's come from ears, from eyes, or from touching, because every signal has same physical properties. It is electrochemical signals. In this case, mathematical approach of artificial intelligence works similarly. It doesn't care what type of data it is. It has to be translated in such a way that it could be processed. And when we have data, we use so-called training algorithms, and we train those with the computer, not that one, but that one. Actually, it is a monster. This computer is a monster. It has it's an IBM supercomputer called Sequoia. It does 17 petaflops per second. I will not explain what means flops, but it means a lot. And actually, when the neural network or any type of artificial intelligence it is trained, and then we will get something like this. It's all about number. If we have bigger structure, this equation can be bigger, a lot bigger. And what is happening here? It's my question here. If we end up with the numbers in the equation, then where is an intelligence there? And maybe from here is coming a bit of challenge that you have to explain why this equation is so scary or so impactful. And many people are talking about, many researchers that works in the AI field, and not only those people, they're talking about three types of artificial intelligence. It's called narrow AI. Now we use those commonly in our phone, like a speech processor. We use those like a chatbots when we want to order some kind of product place to another. The second stage of AI is it's called general AI, where the mental capabilities, cognitive capabilities of human and man-made intelligence are equal. And we don't have at the moment such algorithms that will be equal to human cognitive capabilities. But we are going there. And then the second stage is that super AI, which is so big that we cannot comprehend, cannot control it. And I usually like to compare that with the sentence how to explain to the ant why we are cutting the trees in the forest. It's impossible. And if we will have such type of super eye, I guess we will not feel that at all in this case. Now I'm going to the main topic of my presentation about non-technical challenge. And one challenge, I guess, it will be coming from the natural human emotion. It comes from fear of unknown. What will happen when we will have, for example, general AI? And this fear is, I guess, it has the beginning of that from popular art, from popular movies, which started in early 40s, 50s with the sci-fi-like movies. For example, the movie Roman, Robot Monster, and it's the movie about that some kind of robot comes to the Earth from the moon, and it starts shoot with the laser eye. It grabs the woman, and several men are trying to fight with this robot, and there's the story about that. The Steel Killer robot is also about that. I don't know why robots wants to take the woman. Usually it's a pretty nice looking woman, and it wants to conquer the whole world. It's strange, but at that time it was that the robot is used only for one thing. It's a killing, and our parents grew with that information, and that the robots will take over the world, and we have to make sure that it will not happen never. But in real life, in a real situation, we have robots that helps us, makes us more efficient, more precise, and we can do things not working with material, but we can work with the idea. For example, these manipulators can build the cars which we create. Humanoid-like robots can do also certain things that are usually done by people walking, bringing something. This is a Kiva robot, which is used in Amazon warehouses. As I know, at this time they have 45,000 of this robot, and the main task of this robot is to take the shelf from one place and bring it to another place. But again,
and Vidas, sorry, just to mention that we are a little bit over schedule, so we should wrap it up in a 4 minutes or 5, if that's okay. And anyone who wants to have
I can do it. I can do it. Yeah.
Okay, because and just to tell that it's everyone who wants to have a little break, you can do it right now, and we are going to have like 5 minutes for the presentation and questions and answers, but we are not going to log off from the button.
Okay. Then other fear is losing of job. And there was a questionnaire for American people that were asked how they think that the robots will take over their jobs. They said 65% that yes, they will take over. But when they was asked that they will take over your own job, and they answered no, they will not take the job. And about that wrote Martin Ford. There's a lot of professions that will be taken over by the robots. And one example of that is the Baxter robot, which it trains by looking at the person, and you don't need to program it. It will repeat your motions when you show it. For example, humanoid robots, it's becoming more and more human-like, and they can replace actors in the movies. They can replace fashion models in the fashion shows. We have barista robots that make coffee. We have robots that can paint the art. It's done in 70s, and the paintings are sold in all world. We have robots that can write rap, but there has to be more interesting job than doing that annoying pick and place job. For example, we can work with microbiome. We can create space nursing, space tourism, robotic avatars. We can create a market or technologies which can improve our body in order to be better, for example. We can create technology that can print our tissues, and maybe we can print our brains where we can copy our thoughts and ourself to the hardware, and then transfer this data in the printed brain. Then there is other fear, which is about unexplainability. And unexplainability comes from the method which we are used today to create artificial intelligence. It's called black box. Artificial intelligence takes some kind of input of something. It's, in this case, it's the medical images, and artificial intelligence says you have to cut off it right away. But when the medical person has to explain for the patient that he has to do a surgery without explaining why it should be done, it's really not understandable. Therefore, there is a new trend that's coming called about explainable AI. But the AI today can outperform human clinicians when you want to detect the breast cancer. There are technologies that can fight with your addictions to drugs by using technology. Or you can insert the insulin robots that inject the insulin in your guts in order not to poke yourself every time with the insulin with the needle. We have coronavirus, and you know that there is a lot of people are sick with that virus, and we don't have so much medical stuff that can able to diagnose the images from X-rays, and the automatic way is one way to do it more faster, more robust way. I guess the biggest non-technological issue is the fear of human to let in a technology, not only robotics, any type of technology. Therefore, I'm proposing for you not to be afraid, but be a creative with the technology.
Good morning, everyone. I would like to thank the organizers for the invitation. I will start by introducing myself. Normally, that's what we do in presentations. So I'm Grigoris Hadjikostas. I'm indeed the Vice President of Business Development at Foodscale Hub. And at Foodscale Hub, we really believe in the use of robotics for the agri-food sector. But since I started about introducing myself, let me talk to you about my childhood. I was born in 1977, and I'm this gap generation between Generation X and the millennials. So when I was a kid, I grew up with pictures like that. These are like really pictures from the early 80s that I was reading what robots can bring to society and how our farms would look like in the future once we start using more and more robotic technology. So this is how the artists were imagining the year 2020 that robots would look like. And these were the books that my father used to buy for me. So it inspired lots of ideas about how the future would like. Unfortunately, the future is not exactly as we can see in the pictures, but still it's a bright one and a very interesting one. I know this is not a psychoanalysis session, but still I would like to continue speaking about my childhood. I was also, as a kid, as you can imagine already, I was a rather nerdy kid. So I was also inspired by the trips to space, by the trips to the moon. And this started a little bit before I was born. I'm not that old. It started in the beginning of the 60s when President Kennedy announced that our mission is by the end of the decade to go to the moon. And this was one mission that was really accomplished because on the 20th of July in 1969, Neil Armstrong and Buzz Aldrin really landed on the moon. And Neil Armstrong really walked on the moon. Today, in 2022, what is our man on the moon moment in Europe? It is very clear. It's the Green Deal. It's the mission that EU needs to be climate neutral by 2050. And 2050 is not so far away. It's less than 30 years from now. So this is a very ambitious, but yet vital goal for us in order to be able to understand how this will move forward as a society. And the European Green Deal indeed can be supported a lot by robotics. So that the contribution of robotic technologies into broader societal challenges and into broader societal goals is much, much better. A few ideas of how this can happen is by using robotic technologies for resource optimization and minimization of waste, better use of energy, reducing greenhouse gas emissions, introducing concepts of circular economy, allowing to work in harsh environments that humans cannot really go. And these are just a few examples. Many of you might be familiar with this picture. These are the 8 pillars of the European Green Deal, the 8 priorities, the 8 thematic priorities. And apart from that, I would like to point you at the lower right, as I see it, part of my presentation, which is also another non-technological but yet very important societal challenge. Leave no one behind, making sure that the transition we're making from the fossil economy to the new economy, to the new Green Deal Europe will not leave people and will not leave the most vulnerable and the most weak people behind. So what I will try to do now is I will try to give you a few examples first about, for the 8, let me go back here, for the 8 different pillars of Green Deal, how robotics already are contributing or they can contribute into those broader societal goals. When it comes to the zero pollution ambition for a toxic-free environment, look at this indicative project. It's about manipulation of nuclear salt and segregation. It's about the nuclear waste that it's very difficult to handle, and how the project can work in autonomy, telemanipulation, and other aspects in order to make sure that this issue is dealt with in a clean and safe for the human labor way. Preserving and restoring ecosystems and biodiversity, another very, very important aspect. It will become more and more interesting once we realize the consequences of violating the balance of biodiversity and nature. Already we're experiencing that today. So there is this project called Natural Intelligence that is actually helping through robotic technologies to follow the moves of habitats into dunes, grasslands, forests, alpine terrains, in all the difficult terrains that human observants are difficult to attain. This is coordinated by the University of Pisa. Now, my favorite topic, obviously, is farm to fork, and there you will allow me to present two projects that I have been one way or another involved. First one is AgroboFood. This is a holistic project about introducing robotic technologies in the agri-food sector in Europe. This is really a large-scale project supported by EU Robotics and including also open calls, possibilities to expand the ecosystem and to engage many technologies. At the same time, we have Corosect. Corosect is a very interesting project because it's introducing something that many people see as futuristic. This is about insect farming. This is about using robotic technologies to grow insects and to introduce them into the food value chain, either as feed and, allow me to give you a spoiler alert, as a food also. And I have tried food products based on insects, and believe me, they are super nutritional, and there are the technologies today to make them super tasty as well. Then, sustainable and smart mobility. Robots can really help, particularly in the resilience of the transport infrastructures to extreme events. We can use robotic technologies that can help in extreme events where people tend to be driving under panic. They can improve the speed and effectiveness of the solutions. This is a project coordinated by ICCS in Greece. Then, when it comes to building and renovating in an energy and resource efficient way, there is lots of opportunities in the construction sector. For example, this project about cable robot unique systems, cable robots for the building sector. This is also very important because the presence of robotics in the construction sector has been not adequate so far. This was coordinated by Tecnalia in Spain. Then, when it comes to mobilizing industry for a clean and circular economy, look at this important project as well. It's called Maelstrom. So this is coordinated by CNR ISMAR in France, and this is actually a project that helps through an underwater cable robot and one robot called Bubble Barrier to identify, remove, and sort types of marine litter into valuable raw materials to regain the raw materials from the sea, which is you can understand that the profit here is double. And then when it comes to energy, to supplying clean, affordable, and secure energy, one of the biggest problems is how can we inspect and maintain offshore energy infrastructures that are aiming to be the future. This project is exactly doing that, is offering technologies, robotic technologies that allow the inspection of remote wind farms, offshore wind farms, coordinated by Insectech. And now you will allow me to present very briefly a few aspects of our project, Robs for Crops, one of the projects that I'm involved, and I have the honor to work as a work package leader. When it comes to non-technological challenges, but also when it comes to contribution to social development goals of the United Nations, the so-called SDGs. So what was the idea about this project? First of all, we wanted to start talking about the fact that farmers have to tackle serious labor shortages. Contrary to the popular belief that robots will come to take our jobs, in this project we had to anticipate and we had to address the exactly opposite challenge. The project was conceptualized amidst the first COVID lockdown, where the disruption in the food value chains were huge. It was so difficult to find seasonal workers for any kind of work. It was impossible for people to travel cross-border, and this was creating more bottlenecks in the process. But also, precision and safety of the workers was also an important aspect. And at the end, another important non-technological but very human challenge is how can we eliminate repetitive, harsh, boring work? How can we make sure that the people in the farm are doing interesting jobs, are doing the interesting part of the jobs? How can we make sure that the farmer can really have the time and the information to make decisions? Okay, I will not talk too much about that, but you need to understand a little bit about our technical aims. I will try to summarize it in a couple of sentences. Our main idea is that farmers need to be able to use robotic technologies on their existing machinery. It's not realistic in Europe to say that we're going to remove all existing tractors and all existing machines from the field. So we have to create automation implements. We have to add robotic structures in the existing equipment of farmers. And this creates additional challenges in terms of interoperability, but also challenges in terms of integrating legacy with brand new technologies. But also, we had lots of non-technical challenges. How can we educate and train in robotics the farmers? This is very similar to the question that we had to answer before. How can people understand the socioeconomic impact and somehow stop these myths that robots will come and steal the job of farmers? What are the implications in regulation? How can we make sure that the financial sector understands the new technologies so that they can insure and finance the hardware, the robots or the smart implements? And last but not least, how can we make suitable business models for the European farmers that cannot afford individually big investments in technology? How we address those challenges? By working directly with the farmers in real life conditions. We very often say that farmers need to see to believe. And we try to make them see and we try to make them believe in various countries, in France, in Greece, in Spain, in Netherlands, and in various crops that make sense. The idea here is to create an open innovation environment where on-farm trials can be implemented, other farmers can come, look, discuss, disagree, and at the end understand better what robots can do for them and what robots cannot do for them. So, Robots for Crops is very much contributing to specific Green Deal targets. So we want to reduce the use of fungicides by 10 to 20% by using smart sprayers, but we also want to eliminate the use of herbicides by replacing the chemical weed control with mechanical weed control, with mechanical weeding. But what is even more important, we want to achieve all these things and we want to introduce the agronomic knowledge into the equation without disrupting the current production systems. It's not realistic to go to farmers and tell them to invest huge amounts. As a friend of mine says very often, you cannot ask farmers to go green when their accounts are on red. So our biggest concern here is to make technologies that are socially and financially acceptable by the end users, which are the farmers in our case. And when it comes to impact in social development goals, you can see here that we worked a lot with SDG 2, which is about reducing hunger by making sure we provide safe and adequate food and making sure that possible bottlenecks in the value chain can be tackled through the use of automation. We also wanted to make sure that workers are not anymore exposed to such a big amount, the farm workers, to such a big amount of hazardous chemicals and pesticides, and also not so much exposed to the risk of physical injuries. We worked a lot on these two topics, hence we're contributing in SDG 3, which is about good health and well-being. Obviously, we are working on SDG 9, which is about industry, innovation, and infrastructure by creating an infrastructure of advanced technologies and by establishing a network of early adopters. Of course, we contribute to climate action, SDG 13, trying to reduce CO2 levels of the process at least by 50% by replacing heavy machinery with automated small equipment that creates smaller environmental impact, that we can decrease the kilos of CO2 for every hectare used, etc. And last but not least, I always say this when I'm talking about SDGs. For me, the most important goal is goal 17. This is about partnership. And hence, we tried to create a value chain-wide partnership, starting from farmers, going up to policymakers, but engaging also the citizens, retailers, and consumers into the equation, helping them understand what robotic technologies can mean, helping them break the myth that robotic technologies will create food which is artificial. We're using artificial intelligence to create natural food, not the other way around. And I think that this more or less concludes my presentation.
Okay, I'm going to make it in full screen. Is it okay with you?
Yes, that's perfect.
Okay, so hello everyone. I'm glad to be here. As Lucas told you, I'm Agnès Delaborde. I'm from the LNE, the French Laboratory for Metrology and Testing, and we are a partner of Robotics for You project. I'm going to tell you a bit about one of the objectives of the project, which consists in designing a model for the assessment of the maturity of robots. So first, as you understood, we are exploring in the project 5 different categories of issues. We consider that those issues and the extent to which they affect the acceptability of robots are a key component of the notion of maturity of a robot. So, for example, we consider that if ethics issues are solved, it could contribute to a good level of maturity of a robot. As you understood as well from the first presentation by Annelies, we base our work on massive consultation. So from the general public, the citizens, research, academia, industry, stakeholders, and also policymakers. So we host a lot of public events to gather information. Here, we want to understand, in the context of the maturity assessment, our objective is to design a grid for assessment that will help people to understand to what extent and through which means a robot can be accepted by society. So, we want to understand what is a mature robot and what is not a mature robot. So we want to understand if there can be some kind of a label, a kind of score of maturity that could be easy to understand by people, and above all, that could be useful for all the stakeholders involved around the robot. We do wonder if this scoring can be performed, how it can be performed, in fact. Shall it be an external inspection, that is to say, someone exploring and observing the robot to attribute this score? Or shall it be the designer themselves that assess, that compute the maturity score of the robot before selling it? Or shall it be, it's another possibility, shall it be the final end user, the person who wants to buy the robot, who can assess the maturity of the robot that wants to buy? So all those are still open questions that we are exploring. We also want to explore the tools for this assessment of the maturity of the robot. We don't want general guidelines like a robot should be transparent because, in fact, concretely, we don't know exactly what has to be checked. So we want to identify and design all the measurement tools. It can be proper measuring. It can be also observations, not too subjective. They must not be too subjective, obviously. So we want to identify concretely what are all the checkpoints that are required. We also want to understand what is a good score of maturity and what is not. Obviously, we don't want to be an obstacle for the selling of robots because we understand that we guess that the maturity score that is expected from an agricultural robot may not be the same type of maturity score that we expect for a robot that is in our homes, for example. So we guess that there might be differences in what is the meaning of a maturity score. And perhaps there are thresholds that are linked to the domain of application. In July, we hosted a debate in which we explored what can be the tools for measuring, the tools that I mentioned, the checkpoints. We also explored what can be the types of scores that could be relevant. And we also wanted to understand what could be the stakeholders around this score. So who can compute the score and also who can use such a score. Here, I go quickly on that. Here are some other results that we obtained. So, for example, the participants of the debate highlighted that, okay, there must be tools for the producers and some specific other tools for the inspectors. So for the producers, they want tools to help them achieve a high level of maturity. So concretely, what should I do to have a mature robot? And for the inspectors, they need to have those checkpoints to make sure that they can assess concretely the level of maturity. And for this, we need specific and clearly identified estimators, as I told you, something that we can measure or at least observe. So during the debate, the participants provided us some initial ideas that we are still exploring. Concerning the scores themselves, what is really important, and we fully agree with that, the score must not be a punishment, telling you that, okay, it's a low maturity score, so you are not allowed to sell it. We want it to act rather like a reward, telling you, oh, well done. It's a robot with an adapted maturity score. Concerning the stakeholders, it's something that we still explore, but we've got received some preliminary ideas. So apparently everyone agreed that the score would be useful for the end users, so the people who are going to use and buy the robot, and also like supervision entities, people who can control and monitor the maturity of the robot, from entities for which those aspects, non-technological aspects, are really important. Also, the participants highlighted that this score must allow a better empowerment of the user. So the user is not only passive and subject to the robot's activities, he can also be active in some way by being able to assess and communicate and react concerning in front of the maturity score of a robot. Here and now, we are still proceeding to our massive consultation to understand the major lines of the maturity assessment model that we want to design. We are still gathering as many references as we can, because there have been a lot of initiatives on the topic. So we are still exploring all of them to understand what are their goals, objectives, tools as well. And we are still in the idea of sharing knowledge with all of you. And this is what we expect as well today, to share knowledge with you about that. That's all from me.
So welcome back. I hope you can hear me. And
Yes, we can.
Chance. Great, thank you. So it was fun to watch the breakout rooms. I was switching the rooms like a TV channel, listening to you speaking. So now let's have some time. Let's have half an hour to discuss what was talked in the breakout rooms, because I think it's one of the most important parts. So more or less 25 minutes. So, and share the insights, what you learned, what you talked about with the others. Okay, and maybe we could start with Agnes. Are you here? Okay,
I'm here.
Okay, I was watching your room for quite some time. I think there were interesting discussions. Could you start with briefing us what you were talking about in the beginning?
Yes, and it was not long enough for us to cover it all, in fact. We started from one experience that was presented by Abdul in his own case, and we took it as a baseline for the discussion. So we considered one real robot that is being commercialized from the company AgroIntelli, and this is a multitask autonomous tractor that goes on the field and can produce several tasks, agricultural tasks. This like tillage, seeding, etc. We explored first what could be the benefits of such a solution. So from what Abdul knows of the system, obviously, but we also do it collaboratively to think of what could be the advantages. So for that, I don't know how long do we have to discuss about that, Lucas, so don't hesitate to interrupt me.
No, sure, we have time. Don't worry.
So from what has been told during in the group, there was a big stress on the environmental impact of the solution. Here we talked about the healthiness of the soil, a system that is able to detect and maintain the healthiness of the soil. There was also a big stress on the notion of agricultural efficiency. And here, because, well, we're talking about precision agriculture, so it means that, well, the robot is not spraying, thank you for the word, so it's not going to massively spray the crops and the fields. It's going to be more precise. So this type of agricultural efficiency, so allowing the crops to be more performing. We explored as well, it was a bit difficult at the beginning to explore that, but ideas came during the discussion to understand what could be the benefits for the farmers. So mainly it was a notion of saving time for the farmers. Making them more, sorry, I'm looking for my word and I'm still reading my notes. So to give them more time to take care of other tasks than being in the field and having a close look on the field. There was also something concerning the way job is performed on the farm. Here, from what I heard, and I understood it my way, obviously, so Ludwig, you can also interact if you want, you can react if you want. I understood that such a solution, a multitask solution, may lead to a new type of job planning on the farms. In my opinion, I don't know, Ludwig, if you saw it like a benefit or not. In my opinion, it might be a risk because I'm not so sure that the farmers are really ready to do that, to be able to welcome such a sophisticated robot and to change the way they perform all the agricultural tasks in function of what the robot can do. But we discussed it when we talked about benefits. There was also another big stress concerning the scalability of such a solution. And here we understood that in other countries, such a robot would face specificities, specific characteristics. Like, for example, as in the example that was provided, in Northern Ireland, such a robot would have to be able to adapt to real small fields, a lot of small fields, and with one of the major challenge could be the presence of a lot of slopes. And we know that in agricultural robotics, a robot going on a smooth surface, plane, I don't know the word in English, like that surface, it has to face different challenges when it's on slopes. We've got the same problem in France, for example, in vineyards, on real slopy fields. There is also one note concerning the potential to scalability, the fact that in this present example in Northern Ireland, the workers have a specific type of work functioning on contracts. And so people, from what I understood, and I'm not so sure, and you can correct me, from what I understood, people, workforces move a lot between plantations, between fields, between farms. I'm not sure if I understood this part well, so don't hesitate to correct me, but from what I can imagine, it's the fact that if I'm a worker working on a farm that is highly automated, when I'm used to working on non-automated farms, it can be harder to plan, harder to adapt. In my opinion, there might be an issue here in terms of scalability.
Okay, and maybe we can hear someone else from the room, from the group, so they can add. I know that Neringa had a separate room, but they later joined with you on the same room. So Neringa, could you join us on what you heard and what you discussed? So let's have a discussion.
So maybe I will join.
Yes.
Vaida, my name is.
Okay.
And we have had a very, very interesting discussion. And we would like to come up with certain ideas. Discussions that we had, they were actually about robots taking the jobs, and also about the contrary side of working more interesting, more intelligent jobs, and not having the repetitive work. So the discussion that we had is basically about more about the Lithuanian side. So I think that it's quite interesting to share. However, some of the views that we have discussed is robotics and agriculture. We looked that the Netherlands are the leading in Europe for robotics and agriculture. And the first place goes to United States of America. In Lithuania, we have talked that we have not only automatization or digitalization problems. Actually, more problems there are as it is in the whole Europe. We have aging farmers who are not willing to bring the changes to their current routine. Also, farmers are not willing and quite afraid to be flexible. So that is quite a challenge that we need to face. Not enough of education. Farmers do not understand the exact benefits. And actually, the conclusions that we came up, let's say, one of the idea is to bring, of course, all of the different people into, let's say, one room so that we all would be on the same page. What I mean by that is bring together all the stakeholders, farmers, government people, and have the same discussion as we have had just today. Explain the benefits, explain of course, not only the benefits, but the challenges that we might face. Explain the better side, and then the outcome that we can have, and we can create a safer and better environment for all. So that was our discussion from our room.
Mm-hmm. And I think I could add, we also discussed about sharing data is so important. The supply chain is huge. So sometimes it's really complicated too. And maybe we are afraid to give the data that we have. So I guess, Vaida, you had the same discussion that it's really important to bring all those people, supply chain elements all together.
Yes, indeed. Thank you.
Yes, great. Thank you very much, Vaida and Neringa. Bringing everyone together, that's really a challenge. And I can see it in all of the rooms, there were some non-technical problems as well, which come very close to the technical ones. Is there anyone in the workshop who would like to add anything at this moment? Because of course we want to hear the highlights of the rooms, but who would like to reply to what Vaida was saying and Neringa was saying about the ideas of and challenges of bringing everyone together? Okay, if no, we can do it later when we have heard from all the rooms. So now let's.
Lupe, you are muted.
Lupe, we can't hear you.
Sorry.
Yes.
So now let's hear from Andrius, Nikitinas, and Augustas. They were in the same roof, both with huge amount of knowledge in the field. Maybe they can share what they were talking about, and we'll have a broader discussion at the end of it. So Andrius, could you tell us more about what you're talking with Augustinas and some other participants?
Well, actually, our discussion was about trust with the robots and knowledge about the robots, and also the public education. How to maintain those robots and how they can, interact with the economy, and what kind of fears can be, let's say, for the ethical, for the data protection, and also for the taking the workplaces out from the people. So it's a kind of more or less as the social problems. So of course we have discussed. Augustas maybe tell a little bit more, but the one issue was about Tesla, which is already electrical driving car without any where the driver can they read iPhone or book everything and else and take a time during the driving time in a traffic jam or something like that. But what we do understood that there is not enough information about the robotics, and actually for the agricultural people there is not enough information that they can use that and implement. It was actually a question about pricing as well. Would be possible to acquire robots for the business, or would be possible to acquire robots for for the even households people if they're expensive? And the question was raised that there is enough educated people or not enough actually people who can maintain all those products. And there is another question was would be people taking the services or robots instead? So let's say for someone it's better probably just to take a kind of service to take a grass or just to clean the rooms instead of having some kind of robot. So that applies also for agriculture. So those questions were raising, and also what we've discussed, which is I think very important one. It should be some message to politicians and some work with politicians that everyone from us agree that robots is vital in our economy. So then there is one issue that politicians also should understand, that investments is needed to the robotic and to science and to education. And then it should be kind of common language from, I would say, business sector and to government persuaded just to little bit do the right policy regarding the old robotization.
Okay, so the financial issues also. Augustas, maybe you have anything to add on what non-technical issues you were talking?
Yeah, non-technical, yes. So if to sum up our kind of breakout room, I would say that the conclusions were that people link the robots with the robots from the movies, and technically in most of the movies, robots try to kill the people, so they are afraid of them. And yes, it would be nice to throw additional millions of euros to foster up the economy from the politicians. So, but this is more or less like a joke. I would say that the true thing is that one of the comparison I tackled on was actually the Tesla car. And in my opinion, it's pure robot because, but there is kind of a difference in between the Europe and the States. And if we are talking about the European Union and, neighborhooding countries, in most of the countries, it's still not allowed to enable the function of Tesla to drive autonomously. So this is one thing. But if we are going to the States, and I've been many times in East and West Coast, people are buying the Tesla not because to be sustainable, not because to drive on electric, energy. People are buying Teslas in the States because they don't want to spend 5 hours in the traffic, which is true, and they are spending that amount of time by, looking at the road, driving 5 miles per hour, and technically spending, one small proportion of their life by doing nothing so special. But still, they have to maintain the focus. And I've seen many, times when people are reading the book, playing games via the iPhone, or sleeping while Tesla is doing the driving. So this is value for the money, I would say. Now, if we are coming back to Europe, in my opinion, I will not go a lot to the infrastructure for the electric cars, but it's a hype and it's a bust still. I mean, yes, we want to be super sustainable, super green. That's why we are buying the electric cars. Do they really worth that kind of money, and do they really do the job, and do they really robotize and automate the industry? Most probably not. So in my opinion, this is good and bad example. From another side, we were talking that technically people don't need the robots. Nobody needs. And people don't need the digital technologies and the innovations as per se. But for the past thousands of years, when the innovations were coming up to the market, they were coming up because of one simple thing. We all, as the human beings, are lazy. We don't want to do the boring things, and we want to live comfortable life. So starting from, I don't know, carriages carried by the horses, going to, kind of autonomous moving parts and moving vehicles, going to the phones, which enables us to talk with the people. All the innovations goes because we want to live comfortable life, an easier life, and more fun life. So robots,
yes, and Augustus, yeah, I get the idea. Could you a little bit lower the volume of your computer, because we can all hear me and yeah, I think there are quite a few points where we can get into a discussion with you here, and I can imagine some people would like to do that. Let's maybe have some time for that. So, is there any questions for Augustus or reactions? You can react on the side or go to the queue to have a question, because Augustus had quite some interesting remarks. If no, let's hear the others from the other rooms, what they have to share with us, and then we still have some time to discuss. So I want to ask Kęstutis and Vaida. They were both in separate rooms, but I saw there was a lot of action happening. So Vaida, maybe you could sum it up. I heard there were some people from academia doing research on agricultural and technology. So it would be interesting to hear more about that. Vaida, are you here?
Hi, Lucas. I have already introduced.
Oh, Vaida, yeah. So you did the introduction shortly, yes. And yes, you did because you then moved to the same room. So Kęstutis, could you answer? Are you here? Okay, maybe Kęstutis is not here. I saw it was very active in his room. Okay, so let's have 5 minutes for anyone else, because it's not only the moderators of the room who were important in the discussion. So who has any questions, or would be interesting, who has changed their opinion in what are the main non-technological issues in agricultural field, in robotics? Is there anyone who heard something really new today, or is there anything that changed your mind? It's an open floor for everyone. Just raise your hand while we are waiting. There is also Valdes and Martinez, who are the moderators of 2 more rooms. So Valdes and Martinez, could you answer? Maybe you can answer my question. I know your rooms were a little bit less active. There were less people. So what were you talking about?
Yes, so I can actually try to answer your question, which you just asked.
Great.
Yeah, so I basically did not change my opinion overall, but mostly I just changed my emotion about this the topic that we just talked about non-tech issues. So basically, at first we've discussed that robots might take jobs from people, right? And it seemed to be like a problem of robotics, right? Like an issue. But after Gregory's talk, I just remembered that actually at the current state of evolution of robots, they are just very much utilitarian. They are like tools that are doing our jobs. And we have to consider this as a tool that does some repetitive, boring job. And I don't think that there exists issue like this, like taking jobs right now. Maybe it's futuristic sometime in the future, far away, but right now this is not an issue, I think. And it was actually quite stressed overall that current robots are solving mostly the lack of manpower issue, not vice versa. So that was kind of a change of mind during this session.
Yeah, thank you. Interesting ideas. Martinez, what do you think? You were in the same discussion with Vaidas.
Yeah, so I was in the same discussion, and I can only agree, of course, with Valdas. And during our discussion, we talked mainly about one application, let's say, of robotics. So at first, I have to say that we have also a philosophical discussion, what is a robot? And we agreed that we can call a robot also the software because it's doing, let's say, we can put a software into a robot and it will be a robot. So a software is a robot without a physical body. So what we discussed is issues of connecting all the equipment in the clinics so that they can be monitored. They can be allocated efficiently, and also that mundane jobs, as Valdas spoke about, could be reduced for the staff. So they could use their time that is freed up for better practices, at least. And the benefits, of course, is freed time, less resources needed, so less equipment needed to buy because the equipment is used efficiently. The time is allocated optimally. But the main concerns about is that the Internet of Things, let's say, is untrusted issue for the time being. So what is the security problems and this and so on. Another point that was also highlighted is that different staff members are not so keen on adapting the platform, let's say. Also, maybe some of the staff are better suited for working with such kind of innovation. Another staff is not so prone to learning new things. So we had a little bit discussed about that as well. But all in all, yeah, I agree with Augustus because I think that was the main issue for us as well, that humans are lazy beings and they want to enjoy their life.
Yeah, thank you, Martinez. That's great. So as all you can hear, all the participants here, you can hear the idea of the breakout rooms, and I guess that's a tip for the organizers. It would be nice maybe for it to happen for a longer time, maybe next time. This time it was planned for only half an hour, but the idea is for all of you to hear from real life people, not guidelines, not politicians, on what issues do they feel are important, what issues are there in their countries, what challenges do they face, and what beliefs towards what's interesting and what's important is in robotics and agriculture is. We still have one really interesting presentation coming up, and Justinas Katkus is someone who has to be in the event about robotics here in Lithuania. He's the head of product design at Fact Robotics, and he's going to talk about the examples of good practice in robotics adaptation. So we were like a little bit doing some philosophies here, all of us, and now Justinas, I think, is going to bring us back to earth with his presentation. So Justinas, good to have you here.
Yeah, hello.
Hi,
I'm also very happy to be here. So
good to have you. So we want to hear what you have to share.
Yeah, I actually have been listening here from the morning what my colleagues have been sharing on. I think it was actually an interesting discussion for me also to hear, because I don't remember in my life that I had so many people trying to discuss actually any robotic issues, and this is especially interesting because these are non-technical, which is also quite rare. Of course, in society, we're used to now discussing robotics taking over the jobs and some other things, but I think this is a very interesting and wide discussion.
Yeah,
I
not an
hope I
easy thing to
can.
do online with so many people
Yeah,
and so little
yeah,
time, and with the disconnectings and new tools and so on. But
yeah,
we're trying, I guess.
yeah. But I think we will also have many years to come to discuss that, and some time to adapt before the robots join our lives on every day. So, so good. So I think I have to start in a few minutes, or what?
Yeah, you can start now. Yeah, we are
Yeah.
listening. The floor is yours. You can share the screen,
Okay.
and we want to see the good examples.
Okay. Let's see. Okay. So can you actually see me?
Yeah, we can see it all right. You can
Yeah.
just put the big screen and great.
Yeah. So actually, I'm mostly if my colleague from the morning, Vidas Rodon, is here, the professor from KDU, and Vidas, if you are here, please unmute because I have this slide made explicitly for you. Oh, come on. You're not listening to my presentation? I will give you a call later. But Vidas had made a fantastic presentation generally, and he emphasized a few important points, about AI, which I really think is crucial for everybody to understand these days, because robots become more and more an AI topic for many reasons. And actually, he mentioned one robotic company from the US that he gave in as a good example, where he really thinks that that's a fantastic company. And actually, it was a fantastic company. It was, but it went actually bankrupt. It's one of the biggest failures in robotic market. I think I'm now really getting ready to doing a presentation on why so many robotic companies fail. But actually, the Rethink Robotics has raised over $60 million in the US, and they have been closed down. It had a promise of bringing a standardized, cheap industrial robot, which could be used in any setup in the market, and actually they didn't manage to achieve that, and that's they had many problems on the way, and of course they wanted to make it a very competitive price so that it costs less than $30,000, everything included. They also wanted to make it quite universal so that the robot can have different grippers, can work on different operations. And there's also a cobot. A cobot means that it's a collaborative robot, so actually people can work next to it. It's able to determine whether it's hitting something or is about to hit, so it's a very safe robot. So knowing all of these things, it makes it a very complex system. And I think that people, as always in the hardcore engineering business, really have underestimated the complexity of this robot, and actually have failed in delivering this product, and then the company had to close down. And this is unfortunately a trend that we see in a lot of robotic companies that really try to do something very, very innovative. But today I'm not talking about that. Today I'm trying to do a wrap up on really some fantastic ideas and good insights that have been shared today on these non-technological challenges. I try to group a little bit, but from what I hear, I really see sort of three classes of problems or challenges, and it's the social, economic, and ethical. I will try to go through a little bit on each of those and how I think these could be addressed or are being addressed today. Lucas, I'm sorry if these are not very specific examples, but that would require a lot of time to really prepare different specific answers for each special social challenges or whatever. But just for people to grasp a little bit from a person like me who is in the robotics industry, how certain challenges are being met today. So if I look at social challenges, I try to address it as a person. So for example, as a person, and I have seen many people working with different kinds of robots, both industrial robots, both logistics robots, both robot toys, both whatever, medical robots. The typical questions typically are, how do I interact with the robot? And that's the field where I'm also very keen on, robot-human interaction. And the next problem or challenge is how will I work? How will it work with me? It's a little bit of the problem of how do I interact with it? So how do I make it do something with me, or how do I program, or how do I insert it in my everyday life. And then of course the fear question is it actually safe? So that touches every robot out there, including your vacuum cleaner, including lawn movers, including robots in industry, including a logistics robot. Every robot is feared, especially from the people who have not been watching, like children have been watching movies or whatever where robots are friends. And let's say that these three social challenges, the way I see them, is the top three. And a few best practices that we, for example, use today in industry, what we do in trying to answer these three questions in our company, for example, where we do a standardized product for metal industry, we try to do demo days. It's something what we call in different companies. They register 3-4 companies a day, and we give them a hands-on day, and we actually let the people meet the robot, let them with our engineers or with our support team work with it, answer all the questions, and really sort of help them to get acquainted. And this is at least in something what we see is a super helpful and must-do activity for people to start adopting robots, especially in industrial setup, much faster. Now, if we look at some best practices from a little bit other area, and I love robotics toys, and children are the best class of users. Look at how the children apply robots for everyday activities. There is now tons of learning toys, tons of learning material based on robots, including small robot action programming, including word learning, many different tools. And I'm sure that these can be converted into a lot of helpful tools for different other setups, also helping people learn interacting with some robots. I think even for older people, older generation people that are not that good with technologies, I think we can do a lot of their education with the help of children robotic toys, where you could simulate different setups, how even players house or household, just for people to get acquainted to the idea through play and learning from children. And some best practices also on the household robots. And as I always like to joke, probably now the most common fear case at home is that the animals fear the robots the most. Now everybody is okay in having a Roomba or an iRobot or any other vacuum cleaner, at home, and these, using it very close to you is helping a lot. When I finish this, I would really like people to come up with more social challenges, and maybe somebody else will have some questions that I can try to answer how we would solve that as robotic specialists. A little bit on the economical challenges in industry. That is the next killer question, as they say, and then that is actually, how do I know it will work? And that for people is actually having one question in mind: what happens if I pay money? Will it actually work? Because industry is really has high standards. People never buy a technology that is new. People never buy an innovation. People always want a ready deal, sort of, to say that they can see that it's working, that they can see that it does the work. Only then they're ready to, as I call it, to vote with their wallets and sort of acquire the technology. That's why here, what we try to do, we really try to have adoption success stories, is to really have people share, how they have adopted robotics, what steps they went through, and sort of have even do meetings for people where they can hear from real people that adopted to that. The next economical challenge that we really see is actually the robots are still very expensive in industry, and systems can range from 70, 100 to millions of euros. And for some companies, and especially SMEs in Europe, that is still a showstopper. And there is a whole other avenue that we try to address on new business models. And probably some people have heard of something that is called the RAS, Robot as a Service model, which is actually being very much applied now in farming industry and robotics in farming and agriculture, because the farmers don't need to own the robots. They need it for some specific seasonal work. So this is where they can rent it for some activities and then give it back. So that's we're looking into a lot of new business models, which should sort of address these non-technical economical challenges for companies where they can have better chances of acquiring robotics. And as I just answered in one of the rooms where we have been discussing, I also think that one of the big drivers in removing obstacles for owning a robot is something that I call commoditization, is that the robots will become a commodity in terms of their price and the accessibility. And just last year, the typical price of a robot vacuum cleaner fell below $100. So it means it's a commodity. It means millions of hundreds of households can actually acquire it today, and it's a common commodity technology. And this is where most of the robotics hopefully will go, but that's from another perspective. Last section that I see, I'm not an expert in ethical issues, but I try to address a few here that I have seen. And so, especially if you have sensing systems which can collect different data, is it visual camera, sensor data, or whatever, and here comes the case with Roomba robots, where they really had a big data leak, and then people really investigated and found out that actually all Roomba robots have been collecting data and not allowing people to know that they're collecting data about their apartments. So actually calculating how many square meters, how many things they have on the floor, and many other things, and providing that to who knows who. People became really sensitive. What actually does a Roomba know about my apartment? You know, what can it distinguish and things? And then as one person here nicely addressed, that we should have more expensive household robots. I'm not sure, because they would have much more sensitive sensors and would be able to distinguish in many things that you have around in your home. And I'm not sure if you want the robot to know about it. Another thing is of course that we will be addressing more and more is how do we, when we will see more robots coming into our everyday life, and that's the closest is with telepresence robots, the robots that enable you to be in another place over the distance. So we'll be actually addressing issues, you know, whether a physical person really needs to be present, and then some people might start feeling left out, that suddenly you don't need to come to the office, or if you're not a nice guy, you know, we will much rather have a robot, and some other things. This is just for the ideas, which will come through these non-technical challenges will come through adoption, and we will be seeing them arise. Now, I try to also switch this question from another side, you know, about these non-technical challenges. And I try to address one thing. What if I wanted to attract more robots as a labor force now? If I would be looking from an industrial robotics perspective, or a factory perspective, or whatever, who's applying industrial robotics, and say, what do we need to do if we want to attract more labor force as robots? And 10 years ago, the biggest driver was actually to remove people that we could, because this way we would actually have more profits, to put it bluntly, but that was the main reason. Only the next thing was to increase production capacity and then quality and whatever. It was cost cutting. Today, we have a hugely different picture, and that's the biggest driver is actually lack of unqualified labor force. So companies cannot find people anymore. That's what is driving the biggest adoption of robots now, and they're actually much more keen into going into learning, adapting robots, trying new things out, investing, and whatsoever. And only the next things are process optimization, making things, you know, better. And of course, the EU needs to stay competitive. That's also another huge driver. And then, of course, increase in production. So that's to also understand a little bit the picture from the few sides here. So now, to sum also a little bit up on this few non-technical challenges, if we want to adopt more robots, I would say that today the market, especially from the industrial robotics perspective, is still very much integrated companies. So it means these companies which sell non-standard robots. So you cannot buy it as a standard vacuum cleaner still if you want to do standard operations, and that's still a little bit problematic. Another thing, as I said, is the biggest is cost of the adoption of robotic technology is still quite high. Bad experiences, as I mentioned, where we need really good robot adoption stories. And of course, the whole social environment is the impact on the workspace, the impact on you know on how people feel about that, and some other things. Now, if to wrap it all up, after being some years in the robotic innovation business and really trying to build a standardized, simple robotic system, I can clearly today say that market doesn't need innovations. What a market needs is a very simple and typically a very simple and a very standardized working robot solution which works, which people can understand, and which has a very clear and understandable business case. Is that I buy it, I use it for this, it saves 3 hours of my time, which I can use for my reading or TV watching. That's more or less where robotics is, and that's how simplified it should be if we want to adapt, if we want to sort of adopt it more broadly. This is it. I will stop here and open my panel for questions and then some other things.
Yes, Justinas, thank you very much. Really, we have already questions, and let's hear those. And everyone who want to have questions, just raise your hand. So, Agnes?
Yes, thank you. And the presentation was highly instructive. I had one small question. Well, many questions, but I'm going to ask only one. It concerns commoditization. You talked about making the robots more accessible, and notably in terms of cost. It seems really interesting, but do you have any concrete idea on how we can make sure that, for example, costs are okay? How can we control that?
Yeah, for this question to be answered, I have to tell you that this has to be divided into different verticals. It will be very different for the cost will be very different for industrial robots compared to a household robot. And then you have to look by different sort of how to say industries, and then you have to look also by different applications. What drives the cost of the vacuum cleaner does not drive the cost of their industrial robot. And that is very much driven, of course, by the potential addressable market. And we all know that you can sell hundreds of millions of vacuum cleaners, right? And everybody needs that. But no, not everybody here probably knows that we only sell only 400,000 new industrial robots every year. So that can be in hundreds of times of difference in the market. And when we talk about vacuum cleaners, of course, when there is 500 million customers out there, you will drive the cost down because there's so many companies innovating and there's so many companies producing it on scale that actually the cost will go down. What took, for the industrial robotics to reach the sort of standardized, accessible level below, let's say, $100,000, it took probably the industry a good 40 years. But what it took a Roomba, it took an iRobot company, it actually took less than 15 years. So we will start seeing these in different verticals, but I think it has to be driven very much by demand and then some other factors.
Exactly. So, okay, thank you. It's a good way for us of analyzing the problem, but still the solutions are not really in our hands. I know, for example, in agricultural robotics, the cost of sensors, certified outdoor sensors, it can raise a lot the cost of the overall device. So yes, so no solution yet, but we can still encourage in using more accessible sensor, not doing more than what is expected from them, in fact.
Yes, that is correct.
Okay, thank you.
Yeah, thank you.
Thank you, Agnes, for a great question.
Yeah.
Do we have any more questions for Justinas from the participants? Adriani, I think you can ask anything about industrial robotics to Justinas. Aurelius is asking, just a moment, it's loading for me.
Yeah.
What would be your prediction for industrial robotics implementation rate due to global world market?
Yeah.
And I guess that's the shortages are what we're talking about.
Yeah, we're talking about the shortages. So the global, let's say the global adoption. Well, this is a tricky question because if we want to talk about the industrial setup, then in the industrial setup you don't only have the industrial robot arms. You then have to talk about logistics robots. You then have to talk about many other robotic systems, and then it would be quite a complex picture for me to add up, and that would require probably to chew up some numbers and have this answer in a correct way. But I can answer a little bit on the industrial robot arms, which is a sort of mostly where we have most of the data from the industry over many years. So the adoption rate over the last 10 years, the numbers have really not grown that dramatically. So we're in the range of 300 to 400,000 new robot arms sold every year, and that is quite stably going. The last 5 years, it's fluctuating around plus 20, 30,000 robot arms. Most of those are, of course, going to Asia. What is also interesting is that the total robot amount that we're using, like an active, how to call a population of robots, if that's the wrong term, but an active amount of robots working in factories globally are not changing. They're every year around 4 million robots. So it means some of the robots are being taken out, some new ones are coming in. So that's the whole sort of picture. It's not that many. I would also be expecting a certain rise at a certain time, but there is a very popular trend now that the cobots will come, and these are not the typical robot arms. These are the robot arms that can work next to people. That's why they're called not robots but cobots. So people expect that cobots will actually explode, and they will be sold in much bigger quantities because they will be able to address different work, different work that the sort of hardcore robots, the non-collaborator, have not been able to address. So we can start seeing dramatic increase in these numbers, adding maybe another 100 or 500,000 new robots in a different category.
Yes.
So this is a complex picture. Yeah.
Yeah, it is, and thank you very much, Justinas. I have to clarify the question. By the way, it was, you kind of more or less answered my question, which I kind of thought it is, but Aurelius just clarified that he's talking about workforce matter. So, what would be your predictions for industrial robotics implementation rate due to the workforce market, which is in Western countries is now not
it
at
has
the best?
It has to grow. It has to grow because there are still so many countries, including the EU itself, that has very little adoption rate. And Lithuania is also one of these countries where in Lithuania, if you would guess how many industrial robots do you have, you would never guess, and the number is way below 1,000 robots. So I mean, there are so many countries where we have not even started scratching the surface, and I think this will grow. I don't think it will grow dramatically. It will go in certain waves. The companies that produce these robot arms also have to be able to supply these robot arms, which is also a huge problem for a lot of robotic companies right now. The supply is really not able to sort of fit the demand. So a lot of interesting things going.
Yeah, so you would expect for the demand to grow because of the
of course.
So one of the waves are going to start now, right?
Yeah.
Great. Thanks, Aurelius. Thank you very much for your question. Great one. Do we have any more questions to Justinas? It looks like no. So Aurelius is saying thank you. I'm saying thank you too, Justinas. Thank you very much for joining us. A very clear and defined presentation, very down to earth as always. Thank you very much, Justinas.
Yeah, thank you. It was a pleasure.
Thank you. Yeah. So we just had Justinas, and thank you for all compliments. We are about to end the workshop. I know the lunch is coming, but please stay with me for a moment of view. We want to do it on time, and we want to do. Yeah, I can see your hands going up, which is nice to see. I know it was quite a quickie the whole event, but let's just do once again the short polls, which is also a formality of this event that we have to do. And there are no more open-ended questions, just a few poll questions to get the idea on how much did your ideas about the non-technical challenges changes. So if you could stay with me for 2 more minutes, let's just go through it once again. So the organizers are going to see later how much of your opinion changed after this workshop. So technological progress is more important than social progress. If you can remember what you said before, let's just vote on what we think it is. And we are not going to hold you for any much more longer. I can see Wait, I think it was quite different last time. I think it was quite, oh yeah, okay, now disagree is going up, so. Okay, a few more. Okay. Yes, let's make a few more. Let's at least half of us, let's vote. Or okay, more or less we have the idea. Disagree as the last time, as I remember. So the next question is, I believe the various aspects of robotics are discussed sufficiently in the public discourse. Has your opinion changed about this one? Mine, okay, I can see the answers. No one fully agrees. Yeah. Same picture as before, more or less. No, there are some who agree. Okay, 17 out of us. Let's finish it. Disagree, as before, as I remember. We disagreed with that before too. Okay, our next question is, I believe I am aware of the non-technical issues the robotic industry faces. So do you think you understand the issues? Do you not understand? You are aware or no? So let's vote on this one. This is an interesting one on how it all changed during this workshop. Thank you for being so quick on the answering. Yes, a few more. Are you here? No. Okay, let's do it. So, yeah, most of us agree, even though there are some who are not sure, but most of us would say that we are agree. Okay, the next question is, the workshop helped me to improve my understanding of the issues robotic faces. So this is a way for you to also give some feedback. If just be open and tell us how you feel. The organizers will be thankful for your input. Okay. Still receiving answers. Thank you very much. Okay, yeah. Okay, more of you are voting here, and let's end the poll. Significantly, that's very nice to hear, and moderately, quite a lot of you. And this was new to me, and only one slide, and not at all. There should be like some critique for the everything. So great, thank you very much. Thank you for answering. Oops, a few. One more poll, I think. One more question is left. Just keep it for a moment. Yes. The issues robotic faces, and yes. Okay, I think there is a need for a tool for assessing the maturity of robotic solution and its suitability for adoption. Oh, I have to read it out for myself. Okay, let's vote. Okay. And most of us agree with this, fully agree. And also, I'm not lying, but it's my bad, but there are a few open-ended questions. So my bad. I know you're still maybe want to go to the lunch, but let's do this really quick. And pardon me, I thought there are no open-ended questions at the end, but there are a few. And yeah, let's do them really quick. Who should be doing the maturity assessment on robotic solutions? So who should be doing the thing that you just voted that should be done? Who should be responsible for it? Also, if you want to see the answers, you can just write a letter, let's say a letter N in the results, in the answer, and then vote for the result, the one that you like the most. And if you voted, you can already see the results, and they're quite okay. They're quite different. Let's vote on the answer you like the most, and let's stop the poll. Okay, the most popular answer is quite a popular one, is government and scientists and farmers all together, which is nice. Okay, a few more open-ended questions. Who would be the most interested in the maturity assessment tool? Would it be you? Would it be organizations? Would it be governments? Who would be the most interested in maturity assessment tool? Write your answers in the box. That's a good one. Okay, let's vote for the best answer. Okay, let's see the results. And the most popular answer is users. Some of the answers are all stakeholders or government, but this was a tricky one, right? I could see by the speed of you answering when there were some doubts on this question. And 2 more questions. What are the 2 most important issues areas should a robotics maturity assessment model take into account? What are the 2 most important issue areas that a robotic maturity assessment model should take into account? So we are getting deeper into robotics maturity assessment model. So the issue areas could be, education or policy or socioeconomical areas. Okay, we have some quite an easing. It helps us, the answers by others helps us quite a lot. Okay, let's vote for the answers. I'm giving you some more time, it's okay. Okay, let's end the poll since we have quite many answers. So safety and usability is is the most popular answer. Safety and usability as an issue area. Also economic and adaptability and functionality and versatility, which is close to safety and usability. Great. One last question that we have. Let me just scroll it down and catch it. The question is from the other side. What are the least 2 important issue areas should a robotics maturity assessment model take into account? So we asked about the most important. What are the least important issues? Okay. Some funny answers here we have. Okay, if you voted, you can see the answers and you can vote for the one you like the most. yes, you can put the letter N if you just want to vote. That's okay with me. That's my idea. Because sometimes it's really hard to. Yes. A few more minutes. All issues are equal, someone is saying. Okay, I can see the winner here. So the winning answer is color and fabric. And thank you, someone, for this nice joke. So, well, not really a joke. It's also an opinion. So, great. Thank you very much, everyone, for answering the polls. I guess you're already hungry. And thank you, everyone, for participating in the workshop. Please be sure to leave some comments for the organizers if you think someone could be done in a different manner or anything. So thank you very much, everyone, for joining. I guess it was. I hope it wasn't too fast. I hope I wasn't speaking too fast. And robotics is really an interesting topic to talk about. And thank you, everyone, for your nice emojis. So see you in some other events. Thank you very much again, and have a good lunch. Bye, and see you.
It was great. Thanks a lot.
Oh, thank you.
Bye-bye.
Goodbye, everyone.
Bye, everyone.
Thank you. Bye-bye.
Nice organization. Thank you.
Thank you.